Haloalkanes is the halogen derivative of alkane, organic compound containing halogen atoms such as fluorine, chlorine, bromine, or iodine is called haloalkanes. Monohalo derivatives have the general formula CnH2n+1x or Rx, where R represents the alkyl group and X represents the halogen atom. Haloalkanes are also known as alkyl halide or halogenoalkanes. The members of the haloalkanes homologous series have a functional group of halogen attached to the sp3 carbon. Haloalkanes classified as primary, secondary, and tertiary depending on the number of alkyl or aryl groups attached to the carbon atom linked to the halogen atom. If there is no alkyl or aryl group attached to the carbon that linked to the halogen, it is called a metal halide. If there is only one alkyl group attached to the carbon that linked to the halogen, it is classified as primary alkyl halide. When there are two alkyl groups attached to the carbon that link to the halogen, it is classified as secondary alkyl halide. And if there are three alkyl group or aryl groups that is attached to the carbon atom that link to the halogen, it is classified as a tertiary alkyl halide. Let's have a look at example on how do we classify each haloalkanes. For the first structure, this is the carbon atom that directly attached to the halogen group. Since there's only one alkyl group attached to it, then it is classified as primary haloalkanes. For the second structure, this is the carbon atom that attached to the halogen group. Since there's three alkyl group attached to it, then it is classified as tertiary haloalkanes. For the third structure, this is the carbon atom that is attached to the halogen group. Since there's only two alkyl group attached to it, then it is classified as secondary haloalkanes. Last but not least, this is the carbon atom that is attached to the halogen group. There are three alkyl group attached to it, then it is classified as tertiary haloalkanes. Since haloalkanes are formed by the replacement of one or more hydrogen atoms in an alkene or cycloalkane molecule, it is named as derivative of the corresponding alkenes or cycloalkanes. So, to give the IUPAC name of haloalkane, it is just the same as we name an alkanes. So, the halogen group will become the substituent. So, first, we are going to find the longest carbon chain. For example, for this structure, so we have 7 carbon for the longest carbon chain. So, this is going to be our parent chain. So, to number the parent chain, we are going to begin at the end nearer to the first substituent, regardless of whether it is alkyl or halogen. So, for this example, since this alkyl group, which is the metal group, right? So, we have here 3 substituents. Right? So the first substituent is found at the second carbon. So this is the lowest carbon. That's why we number our parent chain from left to right. So we have two same substituent, which is the metal, on the second and fourth carbon. And on the fifth carbon, we have the bromo. So we are going to write it down as a single word. So since B is come first before M alphabetically, so we have to put the bromo in front. So as a single word, the IUPAC name for this compound is 5-bromo since the bromine is attached to the fifth carbon. 2,4-dimethyl since we have two same substituent, which is the metal on the second and fourth carbon. Alright, so remember to use the prefix di, okay? Alright, and then heptane because the longest carbon chain is 7 and the suffix is going to be ane. For the second example, the longest carbon chain is also 7, but now we have a bromine on the second carbon, which is the lowest number, so that's why we number it from left to right. Okay, and then we have a metal group, two metal group attached on the fourth and fifth carbon. So as a single word, again we have to put the bromo in front, okay, because alphabetically order. Right, so we have 2-bromo. And then, since two same substituent on the fourth and fifth carbon, alright, so use the prefix di. right? Metal. And then the longest carbon chain is 7, so hept, and also the suffix "-ene". Right, so the IUPAC name for this compound is 2-bromo-4,5-dimethyl-heptane. If the location of two different substituents are same from both ends of the main chain, for example here, right, so we have 6 carbon longest chain, and then we have a metal, right, metal, and also bromo. If we number it from left to right or right to left, the first substituent, our first substituent here is going to be on the second carbon. So if this happens, we are going to assign the lower number alphabetically to the first substituent. So since B comes first before M, so we will put the bromo here on the lowest number. So the IUPAC name for this compound is going to be 2-bromo, 5-methyl, right? And then the longest chain is 6, so we have a hex and then a suffix "-ene. So 2-bromo-5-methyl-hexane. If there are 3 or more substituents present, the numbering will begin at the substituent that leads to the lowest set of number. For example, here we have a longest carbon chain of 6 carbon, alright, and then we have 4 substituents, which is metal, metal, chloro, and bromo. Alright, so since from left to right, okay, the first substituent, we have 2 metal on the second carbon, so that's why we number it from left to right. So the IUPAC name for this compound is going to be 5-bromo, 4-chloro, 2,2-dimethyl-hexane. For a cyclic compound, if there's only one substituent is present, no number is needed. For example, here we have a cyclohexane and fluoro attached to it. So the IUPAC name for this compound is fluorocyclohexane. If there are 2 different substituents present, we are going to number the ring in alphabetically order. For example, here we have 2 substituents, which is a fluoro, right? So we have fluoro and also CH2CH3, which is the ethyl, right? So since E comes first before F, so the IUPAC name for this compound is 1-ethyl 2-fluorocyclopentane. But if there are 3 or more substituents present, the numbering will begin at the substituents that leads to the lowest set of number. For example, here we have metal, metal, and fluoro. So since these 2 metal groups are attached to the same carbon, so this carbon is going to be our first carbon, right? So the IUPAC name of this compound is 4-fluoro-1,1-dimethyl-cyclohexane. Now, let's try draw the structure according to its IUPAC name. So for the first one, we have 4-ethyl 5-iodo-2,2-dimethyl-octane. So we are going to start off with our parent chain. So since we have octane, so the longest carbon chain here is 8 carbon. So we have 8 carbon longest chain. And then we have 4 ethyl. Okay, so we have ethyl on the 4th carbon. Alright, so ethyl is CH2CH3. Alright, CH2CH3. And on 5th carbon, we have iodo. Alright, so I. And then 2 metal on the 2nd carbon. So 1, 2, CH3, CH3. So this is the structure of 4-ethyl 5-iodo-2,2-dimethyl-octane. For the second one, since we have a cis isomer, right? Cis isomer, so the parent here is the cyclopentane. So we are going to start off with the cyclopentane. So draw it in planar, right? So it have 5 carbon, right? So the shape is pentagon shape. Since chloro is attached on carbon number 1 and carbon number 3, so this is a cis isomer. So let's put here Cl, Cl, and another one here is we have a hydrogen, right? So since it is a cis isomer, so both sides must have at least one same atom. With respect to electronegativity, halogens are more electronegative than carbons. This results in halogen-carbon bond that is polarized. As shown in this diagram, the carbon atom has a partial positive charge while the halogen has a partial negative charge. This makes the electrophilic side carbon of haloalkanes is susceptible to nucleophilic attack.